The sound we perceive is characterized by three parameters: the loudness, the pitch, and the timbre. The timbre is the relative intensity of the various partials, or the various Fourier components of each sound. The pitch corresponds to the physical frequency of the sound we hear as a pitch, we perceive as a pitch, whereas the loudness is the human perception of the physical volume, the measurable physical volume, which again we perceive as loudness. Let's watch these three parameters in action. I have a 440 Hertz tone here that you can clearly hear. It's picked up, it's emitted by this speaker connected with the Fourier synthesizer that I have here, and it's been picked up by the microphone associated with this recording. And so if I vary the amplitude, you hear louder for greater amplitude, greater volume of the physical sound emitted by the speaker, greater loudness perceived by our ears. Lower amplitude, lower volume, lower loudness. The frequency, 440 Hertz, of this sound is obviously the physical frequency, but we perceive it as pitch. And the pitch we perceive is very well related to the physical frequency. So this is 440 Hertz. That's 880 Hertz, so twice the same frequency. Then I had 3 times, which is 1320, 1320 Hertz. Then I have a 4 times, which is 1760 Hertz, or 1760 Hertz. Again, amplitude and volume are directly correlated with the loudness that we perceive. Clearly a difference in pitch between these different components. I can put them in and out one at a time, or I can play them all at once as I am right now. And you can clearly see on the oscilloscope that there is a very interesting waveform. All of the frequencies are different. We had 440 by 1, by 2, by 3, by 4 with these 4 Fourier components, and their superposition generates a complicated waveform. That waveform changes dramatically if one changes the phase. As you can see, I'm moving the phase of the third component, and the waveform is completely different, but absolutely nothing changes in the sound that we perceive. What does that mean? Well, none of the 3 parameters includes phase. Loudness, pitch, and timbre, none of them include phase. So what I'm changing is the phase between the phase shift between one of these components, and I'm just using the third one for sake of argument. I could use another one, obviously, and produce different waveforms, as you can clearly see on the oscilloscope. And as these vary dramatically, we hear absolutely no change. Every now and then there is a little bit of a change in amplitude, it's just a change in volume, and we perceive it as a slight change in loudness, but it doesn't at all change the frequency that we perceive, because we are not sensitive to phase. We are not sensitive to the waveform of the sound that we perceive. All we do is use our hearing precisely like a Fourier analyzer. What we do is to measure the frequencies that compose this complicated waveform. So we analyze which frequencies are there, which partials are there, which multiples of the fundamental are there, and so in this particular case we are perceiving that there's a 440 hertz, an 880, a 1320, and a 1760 hertz sound, and we are analyzing just like a Fourier analyzer would. When we hear, our inner ear, the cochlea, and the brain produce a Fourier spectrum, which is how we perceive and interpret the sound that we perceive. Thank you.